Hi, welcome to this presentation or webinar on slightly more advanced performance testing. We're going to look into how to record a script and adapt that script to model real-world user behavior to be able to get the most out of your performance tests. We will set up a test configuration that corresponds to real world load levels. We'll look into what that looks like when we run the test as well. Now, we're going to start off with logging in, which makes sense. And this is where you end up in your account. Looks like this. We will need some way to record our use case or user scenario or user journey. Has many names. Basically, it's a sequence of actions your users will normally do, like logging in and searching for a product or looking for some particular item or reading a newspaper site, traversing through documents, etc. The workflow for a user, basically. We will use the Chrome plugin recorder, which is very convenient for this. It does require that you use the Chrome web browser, and if you have that, you're logged into your account. You go to user scenarios, select to create a new user scenario, and choose the scenario recorder for the Chrome extension. It will be added automatically from the Chrome App Store, or you can find it in the Chrome App Store if you prefer to look it up that way. I already have this one, so I'm not going to install it again. It will show up top right hand here as the load impact user scenario recorder with the very fine crocodile eye. So what do we want to record then? Well, we want to record a use case that we have selected from a website which I should enter the correct URL to, and we'll see what happens here. It's not the fastest website on the planet, and it's actually a really poor website. It's an airline booking system where we will look up departure and destination. We will book some flights, and this is we'll look them up and see if we have any suitable departures, and we'll stop there for this particular use case. Like any airline website, you search for flights, but we will record this into a script. So let's start the recording by selecting Start Recording, and then we will go recording. Going to the website, important to remember, do the first step actually to get there to the landing page. Your users actually get there, and then we will look into booking some flights. And how does that usually work? Well, we usually try to find a departure airport, so we're going to look that up. And I have a departure airport here. And then what do I want to do? Well, I usually want to go somewhere, so I will look up a destination airport. This seems suitable. For those of you who want to know, this is of course completely fake, but the airports actually exist. It's domestic airports in Sweden. So let's find some dates when we can fly. Well, I would like to fly out a Monday, and I would like to... When would I like to go back then? Well, I would probably like to go back on a Thursday. So let's search for some flights to see if there are any, and see if we get some results. Yeah, we did. We did get a number of options, and we would select those that suit us. Uh, but we are not going to go on to book an actual flight in this case. We will stop just there and be happy with that. So we stop the recording, and what now happens is we bring up our logged in user interface. I was already logged in, so it will stick it in here for me. If I'm not, it will ask me to log in. So we're going to name this something, airline version 1. Give it a name in some naming scheme. So if you have several organizations, which you can have, I'm going to go into my default organization here. You can have several projects. If you haven't discovered that, I have set up a webinar project here, and that's where I want to save my scenario. So now I have my recorded use case. We're going to look into the script, see what's in it, what became of it, see how we can update that to match user behavior proper, and see if we can add a few things to make it more understandable when we look at the results. So what do we have here? Well, we have this script that got recorded, and let's take a quick rundown what got recorded. Well, first thing here, we have something called page 1. Pages make sense in a page-oriented or step-by-step oriented user flow, like we did. Step 1, step 2, step 3. We go to the home page. That's the first page we go to. We name these automatically as we move along in the use case. And what happens here? We have a request. It's the default page, the landing page really. And then we have some static content, style sheets, JavaScript, what have you, blah, blah, blah. A lot of stuff. And then we see, moving on to the booking page, interesting. I was slightly too fast there. And we see we have a lot of statics from elements from that page as well. And this is the end of the first page. Pages are a way of grouping your requests or transaction that you specifically want to measure. All tests measure all the individual URLs as well, or individual requests, but we really want to pick out transactions that make sense, like doing an actual login, getting the landing page, including all the stuff that's on it, etc. So page 1, page 2, next step. Oh, a big post here, and another post, and then we have page 3, the next thing, page, and we have a few more things in that page that's happening. This paging is automatic, and then we have the end here, 3 pages. Let's update that to correspond to something meaningful that makes sense in terms of naming. Page 1 doesn't tell me much. It's fine if I know what page 1 is, but I think I like better names. So a number and then front page. That makes sense. Front page, and then we see where the front page ends. I know I actually did this. Going to the booking page will bring this request up, so it seems I didn't terminate the page in the right place. So let's terminate there, and it of course ends with the same name as it started. So I have my first transaction here, really, my first page, the front page. And what is this then? This is actually the second page when I go to the booking. So let's enter a start and end clause for that as well, and name it to booking, which makes sense because I'm going to the booking page. I'm not doing any actual bookings. And let's make sure we end with the same name so we don't miss out. That makes sense. So let's see what we do then. Then we go at the booking. If we remember correctly, we selected a departure, we selected a destination, and then we selected departure and return dates, and then we searched, and we have a lot of requests here that all get bundled into the same page. Not really what we intended. So here it's good to have a good understanding of how your website or web service works, or access to someone who does know. It's not necessary to do all these things to make sure your transactions or pages are exact, but it's a very good way of following the use case and understanding the results. And you might know what page 1, 2, 3, and so on, the auto-generated names are, but when communicating the results and the tests to someone else, especially if you want to talk in terms of business terms, it's very good to name them meaningful things. So the next step was so let's do this rather quickly because it's the same principle. And to booking, we selected the departure. So select departure. As I mentioned, this website isn't really the best website. It's actually a really poor website. We'll get back to the sleep times here. Those are very important, but we'll get back to those in a short while. Once that was done, we selected a destination. So let's give that a meaningful name, select destination, and that was actually that particular request. And here we have some static stuff as well. And there is the next thing. And let's see, and then we did departure date, and I think that was it there. See if my spelling is any good here. Let's name these transaction meaningful things. Return what? Return date. And the final step we did then was to actually search. That makes sense. It's the final part here. Sometimes it can be tricky to determine where your transactions actually do start and do end, especially if you don't have a page or workflow or step-oriented web application. If you have a single page web app, or you have a lot of Ajax calls updating things on your web, etc. Then you can have a lot of transactions that don't really belong in the term of page, but it's still an action of some kind. So you can very well group and ungroup these into pages. So flight, did I say flights or flight? Flights. Starting and ending of these should be the same. So now we have named all the transactions or the pages in this particular flow to some actual very detail. Might not be necessary, it's your choice, but we like to sort of have consequence here. Now to something that's important. We see when we recorded, we got a few of these. Client sleep. Sleep times is actually the time the script spends doing nothing. And doing nothing is actually quite important because that corresponds to the time the user is actually reading or entering data or contemplating the content and making choices and selections, etc., before doing an action again. So that sleep time needs to sort of correspond to real world usage. When we record these scripts, we probably know the use case very, very well. So we're going to be very fast, to the point of the recorder not even detecting any pause between the steps. So we might have to enter some manually. And also we don't need them to be fixed values like 13. We want some type of randomness in there, because not all users are equal. Some are very fast, and maybe your parents are a little bit slower if they're entering dates for searching for flights, etc., while your kids are probably very, very fast on entering dates. So that's just one way of describing the difference between different users. So we want to add a little bit of randomness, so we'll use the random function. Let's say 10 to 15 seconds makes sense. Sleep is in seconds unless you enter a unit. So let's be lazy. Between the first and the second page here, this should be a sleep as well. So we'll add one. Maybe not so long. When I go to the landing page, I want to book. There's not much information to take in before I select the booking. So there it makes sense with 5 to 10 seconds. And then between selecting departure and destination, well, I might need to read and think a little bit about it. So 10 to 15 seconds. And between selecting a destination and the departure date, an interval as well. And between selecting departure date and return date, an interval as well. And once we're done with that, we want to search. But once we have filled out all the elements and selections, we don't want to wait that long. So just a short break, and then we press search. And this is where the script ends. We end with a sleep. It gets inserted by default by the recorder, and it's an average of 20 to 40 seconds. And this is because this controls the pacing of the individual user. When we run the load test, the user will execute this script once, and then it will start over again, and then it will start over again, and then it will start over again until the test is completed. And this sleep at the end of the script controls the pacing between ending the script really and starting the next iteration. So 30 seconds on average is a very decent default. That's why we enter it here. You can make it bigger or smaller depending on your use case, on how transaction intensive you want your test to be, etc. But now we have updated this test, fixed a lot of things here, made it sort of much more real world like, corresponding to what real users do and how they behave. And we'll save that. And now we'll do the next important step. We will validate it to make sure it actually works. This will run the script once. It will make sure everything is correct, you get proper responses, etc. And this, oh, see, I did something wrong, and we see the error here. It seems start search flights must be called before calling end search flights. Well, that makes sense. It should be page start here. So a small error. So let's just validate again. And what this does, it's actually firing up a load generator, running the script proper, but ignoring the sleep times. So validation ignores the sleep times to make validation turnaround time faster. That's really convenient, especially when you have long use cases or long sleep times in your scripts, because it returns much faster. Now we have a working use case in this script that behaves the way we like it to behave. So we're going to set up a test. I have saved this, so let's go into making a new test. And we get this is the default view where we have no test. There's a nice video to explain how it works if you haven't seen it before. Let's do a new test. This is the view you get when you want to do the really fast and convenient test. You enter the URL, the number of users, and you kick off the test. It's good for landing pages and campaigns, etc. But of course, it doesn't emulate the entire use case. So let's go into the advanced mode. The test should have a name, definitely. So let's do it airline, and some naming convention that makes sense for you. I like to name them like this: 5 users, 5 VU. I'm going to run this test with a small amount of users just to make sure everything works as expected, and then we're going to kick off a bigger one. So I'm going to need airline V1, that's what I called it. I want to run it from somewhere, so let's run it from Dublin in Europe. I have a number of different locations to choose from. I choose Dublin. You can of course run the same script from different locations if you feel that's important, if your user base is geographically dispersed, etc. But let's stick with one for this time. You can of course run several use cases together as well in a blend of user scenarios to correspond to real world load. Now what you get here is the default ramp up from 0 to your max level of users, but this has the unfortunate side effect that when you add the last user, the test terminates. So the last user will actually not be able to do much more than maybe the first request, and then the test will be terminated. So what we need is a traffic simulation that makes more sense. We're going to run 5 users only, and it's going to take 1 minute to get from 0 to 5. That's what we call the ramp up time. And then we're going to stay at 5 users for 5 minutes, and then we're going to go down to 0 users in 1 minute again. The ramp down time. The ramp down is good because if we have poor response times at our max VU level, we can see if the system recovers. And then we can select to be different type of browser or device to the server. Otherwise, we'll just identify as a load impact all load browser, which some systems don't really recognize. So we just like to set something then. Stay with the default unlimited network here, not look into any of the limited variants. We're not necessarily in need of several source IPs, so this is a very good setup. And as an extra bonus, I'm going to add a little bit of monitoring. I actually have a monitor on the server we're going to test, the server metrics agent. You have everything here in the monitoring part if you want to do that. It adds collects metrics from your different servers that you have installed it on, and it collects the basics: memory, CPU, I/O, and it's very convenient. It makes analyzing results much faster. So we save this test, and if you like to, you can schedule it. Maybe you don't want to sit up all night when you have a testing window, so you can schedule it, but let's run it. This is what it looks like when we run the test then. Our use case that's modeled after real world users, and you probably recognize this view then. We run the test. It takes a while to boot the load generators, acquire them, put the test on the load generators, and then fire up the test. So we see here we get the load generators, we're deploying the test configuration. I'm going to scroll up here, and we're going to see this. And now we're waiting for the server agent to check in when it will pick up a little bit of information that tells it to start sending data, and should be responding quickly. The server agents collect the basic information, as I said. That's where it usually shows up, but they're very open-ended and can be used to collect almost any data. It's very convenient when you analyze results, not having to go to other systems to correlate data with your actual load and performance testing response times. And here we go, there the agent is online, and we should kick off the test now. Here we go, it actually is located in Lund, the target system. So now this window won't provide more information on the results, so we close it, and we can see up here we have the general statistics, the number of users, bandwidth, request rate. We're only running with this with 5 users, and that's really a type of smoke test or small test to make sure the test does what it's supposed to do. It's really important to set it up properly before we kick off running big tests to get the results. Let's get some quick views. Here we see the pages that we actually spent so much time and elaborately named in a nice order to understand. Here we see them showing up as front page, to booking, etc. So we're going to add these graphs to keep track. I'm not going to add all of them, just a few to make sure we can see. And here we see them, and we see the number of users going up to 5. And we see the front page, which actually corresponds to the user experience here in how fast it takes them to get all the content for the front page. And page 2, how long does it take a user to go to the booking page? And just to show you, we can overlay this up here, and we see the front page average response time, which is sort of half a second, which I'd say is quite good. And now we get our default metric, which is VU load time. Just to spend a short time here, VU load time you will not get until the user scenario or the script has actually completed for at least one user. And it's the sum of all the requests inside the script, not the actual page load time or anything, which you of course realize here when you have the page 1 front page is half a second, and you see the amount up here is 2 seconds. But that's the response time for all the requests together. And it's a very good indicator if you have stable response times or if they're increasing. So let's see what's happening here. Oh, here we seem to have some spike in the response times. Interesting, but looks good for everything else. Final thing, we can add a lot of individual metrics here, but let's just take a quick look at the server-side metrics. Let's look at the CPU. We like to pick out the maximum because it tells us how the server is doing. It's using 10-12% CPU, that's not much. So let's add that up here as well. It seems this particular increase in response time for the front page is not correlated to CPU because the CPU usage is continuously low here. Seems we're doing very well. If it was, the CPU would go up to 100% and that would be it. So now we have set up a user scenario corresponding to real world usage. We've made it, adapted it so it makes good sense in reporting results, looking at the individual transactions or pages. We've looked at the results we set up a test configuration for a smoke test. Of course, you can just set that up for a big test. Just increase the number of users to what you think is reasonable for your target. And that was about it. For those of you who are observant, you noticed we had a lot of dynamic data inside the scripts as well that we can adapt And for the next session, next time we're going to be looking into handling dynamic data, as well as looking into how to make our tests data driven, in the meaning that we can actually provide usernames and passwords to make each user completely individual and handle all the different parameters that you might want to input to make the test data driven.